Hello everyone, my name is Zhuomin Li. I'm from Ocean University of China. The topic of my talk is the sea surface temperature retrieval from HY-1C and HY-1D COCTS in the South China Sea. My talk includes three parts. Firstly, I will introduce the research on SST retrieval algorithm. Secondly, the cloud detection and quality level defined will be introduced. And thirdly, I will introduce the evaluation of the COCTS SST. Haiyang series satellites are marine remote sensing satellites in China. At present, 5 satellites have been launched. HY-1A and HY-1B are experimental satellites. HY-1C, HY-1D, and HY-1E are operational satellites. The HY-1E is in orbit test now. The table shows the HY-1C and HY-1D COCTS spectrum specifications. The COCTS onboard HY-1C and HY-1D satellites contain only 2 infrared channels, 11 and 12 microns. And now I introduce the research on SST retrieval algorithm. The aerofoil profiles, including sea surface and atmospheric parameters, are used to obtain the simulated brightness temperature through the radiative transfer modeling, and the NRSST algorithm is used to fit the retrieval coefficients. And the representativeness of the atmospheric profiles is crucial to obtain a high precision SST retrieval algorithm. The representativeness refers to the large difference in atmospheric profiles, including the atmospheric temperature, specific humidity, and also mass mixing ratio difference of the atmospheric profiles. The update TIGR method is applied to select representative profiles. If the atmospheric temperature, specific humidity, and ozone mass mixing ratio of the profile significantly differ from the selected profiles, the profile is retained. And the figures show the spatial distribution of the selected profiles with the values of SST scheme and the total column water vapor. You can see near the equator, there are less profiles because of high cloud coverage. And in other areas, the profile distribution is relatively uniform. And then the satellite zenith angle are set to 0 to 15 degrees. The interval is 5 degrees, and the simulated brightness temperature corresponding to each satellite zenith angle of selected profiles is obtained respectively. And Gaussian noise of 0.2 K is added to the simulated brightness temperature. The coefficient fitting is carried out using this formula. And more than 5,000 points are used for fitting and more than 2,000 points are used for validation. The VIIRS of HY-1C COCTS validation dataset is 0 and the standard deviation is 0.37 degrees. The VIIRS of HY-1D COCTS validation dataset is 0 and the standard deviation is 0.37 degrees too. And the figures show the relationship between NRSST calculated by validation dataset and the aerofoil SKT for HY-1C and HY-1D respectively. We can see the NRSST from the validation dataset is consistent with the aerofoil SKT, indicating that the algorithm performs well. And we use the obtained coefficients to retrieval SST based on the observed brightness temperature, and then we received the SST from COCTS. And then we perform the cloud detection and quality level define. For cloud detection, the threshold method is used for cloud detection. Cloud pixels always have low BT values or large BT difference between the channels, poor uniformity, large negative VIIRS between SST and reference SST, and high reflectance and reflect ratio of the visible channels for daytime. And we use these parameters to judge the cloud pixels. And then for each pixel, according to the C-line flag, the range of the SST value, the difference between SST and reference SST, satellite length angle, and the uniformity information, the quality level is defined. And we receive the quality level from 0 to 5. And the quality level, the pixels with the quality level of 0 are length, eyes, or no BT values pixels. And the pixels with a quality level of 1 are cloud pixels. The pixels with quality level of 2 are pixels with abnormal SST values. Pixels with quality level of 3 are pixels with large local standard deviations. And the pixels with quality level of 4 are in cloud age or with large satellite length angle. The pixels with quality level of 5 have the highest quality levels. And the COCTS data in the South China Sea during the period of May 2021 to April 2022 are processed, and the skin SST products are obtained. The left two pictures and the right two pictures show the COCTS from HY-1C and HY-1D COCTS SST with the quality level of 4 and 5. We can see there is no obvious phenomenon of judging the clear pixels as the cloud pixels. And these are the images from these are the HY-1C monthly COCTS SST in the daytime. We can see in the we can see the SST in winter and the spring. There are more SST fronts. And from December 2021 to April 2022, there are more SST fronts in the south of China and east of Vietnam. And from May to October 2021, the SST is relatively uniform and the overall SST is high. But from November 2021 to April 2022, there are more SST fronts, which are mostly distributed in the northwestern area of the South China Sea. And we can see from December 2021 to April 2022, there is an obvious crucial inversion fronts in the north of Philippines, and in the central south of China Sea, there is an obvious temporal front. And the characteristics of SST fronts distribution indicates that the cloud detection algorithm and the quality level defined retain a lot of SST gradients pixels. And then we do something about the evaluation of COCTS SST. The local time of the descending node of HY-1C is 10:13 a.m. and the local time of the ascending node of HY-1D is 1:13 p.m. The SLSTR on board Sentinel-3A and VIIRS on board NOAA-20 crossed the equator at 10 a.m. and 1:13 p.m. respectively, which are close to HY-1C and HY-1D respectively. And SLSTR and VIIRS SST have high accuracy and can be used for evaluation of HY-1C and HY-1D COCTS SST. And these are the results of evaluation of COCTS SST from HY-1C. The VIIRS of HY-1C COCTS SST and SLSTR SST is minus 0.07 degrees, and standard deviation is 0.5 degrees. And the left two figures show the spatial distribution of the VIIRS between HY-1C, COCTS SST, and SLSTR SST. You can see the VIIRS has no spatial distribution characteristics. The right figure shows the relationship between COCTS SST and SLSTR SST. We can see most of the mashups distributed in from 28 to 13 degrees, and the COCTS SST and SLSTR SST have high consistency. The COCTS SST obtained in this study is skin temperature, and the SLSTR SST used for HY-1C COCTS SST evaluation is also skin temperature. So the VIIRS is close to 0 in the daytime and nighttime. And then these are the results about evaluation of COCTS from HY-1D. This is similar to the results of HY-1C, but there are some difference in the day and night VIIRS. We can see during the day, the VIIRS of HY-1D, COCTS, and VIIRS SST is 0.03 degrees, and the standard deviation is 0.53 degrees. And during the night, the VIIRS is minus 0.12 degrees, and the standard deviation is 0.52 degrees. The VIIRS SST used for HY-1D COCTS evaluation is bulk SST. So there is a small negative VIIRS between HY-1D COCTS SST and VIIRS SST at night. And then we made the difference between HY-1C and HY-1D to COCTS SST to see whether it could reflect the diurnal variation of SST, and further evaluates the accuracy of the retrieval algorithm. And the average difference in the daytime is 0.38 degrees. The average difference of COCTS in the nighttime is 0.03 degrees. HY-1D COCTS SST in the daytime is 0.38 degrees higher than HY-1C at COCTS SST, indicating the diurnal warming phenomenon caused by solar radiation. These two figures show the spatial distribution of the difference between HY-1D and HY-1C COCTS SST. For the images of the day, we can see HY-1D is higher than HY-1C in most of areas. And then we added wind speed data to analyze. The figures is a time series of monthly mean difference of HY-1D and HY-1C in the daytime. The black line is the difference of HY-1D and HY-1C COCTS SST, and the yellow line is the wind speed data from Armstrong 2. We can see in the daytime, the monthly average wind speed in May is low at around 4 meters per second, and the cross-boarding HY-1D and HY-1C have the large difference, which is 0.42 degrees, and the diurnal variation is large. In December, the monthly average wind speed reaches 8.16 meters per second. The difference between HY-1D and HY-1C in December is the smallest, about 0.17 degrees. The greater the wind speed, the greater the mixing of the SST reflected in the smaller diurnal variation in skin temperature. And in summary, the coefficient fitting method based on atmospheric radiative transfer simulation is used to retrieve HY-1C and HY-1D COCTS SST. And then SLSTR and VIIRS SST are used to evaluate HY-1C and HY-1D COCTS SST respectively. The VIIRS of HY-1C COCTS SST is minus 0.03 degrees. The standard deviation is 0.5 degrees. And the VIIRS of HY-1D COCTS SST is minus 0.04 degrees. The standard deviation is 0.53 degrees. The mean difference in the daytime between HY-1D and HY-1C COCTS SST is 0.38 degrees, indicating the diurnal warming phenomenon caused by solar radiation. The results show that the retrieved HY-1C and HY-1D COCTS SST in this study have high accuracy, and the SST difference between HY-1C and HY-1D is consistent with the characteristics of diurnal warming in this region. And these are the references. Thanks for your attention.